Now, going on to the next one, if we take a look, what if we don't have time? If you notice, in all of our examples so far, we have always had time. And well, I love to have time. Time is good for everybody. But the reality is sometimes we don't have time. And to do that, what we have to do is take two or three of those equations we looked at before, once again go through some substitution, once again go through some rearrangements. If we do all that work, we end up with this equation here in this case. We don't have time, but we have every other variable. We have final velocity, we have initial velocity, we have acceleration, and we have displacement. You're just going to have to take my word for it that this is the correct equation. If you would love to see the derivation of this, we can do that before school, after school. I can walk you through it, how we get to this equation. But for our purposes, just being able to do the equation is probably the most important part here. Okay. So again, we're going to work through a problem with this in this scenario. Now, there's a couple of things we want to be careful about when we're working with this equation that makes it a little bit harder, a little bit different than the rest of the equations that we had before. Okay. If you notice in this equation, we have squared values, both for velocity initial and velocity final inside of here. Now, with squared values, that means we may have to do some square rooting. And if you recall from your math, if you take a square root of something, it's your choice after the square root whether or not you make that positive or negative. So in a problem like this, if we end up getting an answer from a square root, we have to choose positive sign or negative sign. Well, the physics will let us figure that out because are we moving up or are we moving down? Are we moving left or right? What's considered positive, what's considered negative here? Okay, so here we go. You roll a bowling ball at a velocity of 7.66 meters per second down Diffley Hill past McDonald's. I would not recommend actually doing that, but let's say hypothetically that happens. Okay, if that's the case, that is our initial velocity. So our velocity initial was 7.66 meters per second. Okay, down Diffley Hill past McDonald's. Accelerates at a rate of 1.75 meters per second squared, so we end up having acceleration of 1.75 meters per second squared. And it runs for 759 meters, so we have 759 meters. We do not know the time it took. That's not part of our problem. And we want to know how fast it's moving at the bottom. So speed is velocity, so we're trying to solve for this guy right here. Okay, that's our setup. So again, write our equation out. We know that our velocity final squared will equal our velocity initial squared plus 2 times the acceleration times our change in displacement. Okay, so our velocity final squared will equal 7.66 squared plus 2 times 1.75 meters per second times 759 meters. Okay? Which means our velocity final, well, will equal the result of all that square rooted as we do this. All right? So if we take 7.66 squared plus 2 times 1.75 times 759 meters, we get 2,656.5. And the label here is meters squared per second squared, which we want because once we square root it, the squares will go away. So our velocity final then is either plus or minus, right? Because square roots are plus or minus the result of that, which happens to be 51.5 meters per second. Okay, so plus or minus. We need to designate what is positive, what is negative here. Okay, now in my problem, I really didn't do that. So if I want to say that down is negative, then this would be a negative, this would be a negative, this would be a negative. So in my math, that would be a negative, that would be a negative, that would be a negative. That's fine. if I don't want to do all that work, I can leave them as positive and say that, well, down is positive. Either way it works. It doesn't matter. The trick is at the end, you either need to identify what is considered positive, what's considered negative here. The best way to do that in this case, I would rewrite it and say it's 51.5 meters per second down the hill or downward. That way there's no question that you understand that the ball is moving down at the end and it isn't starting to roll back up the other side or something weird like that. Okay? Otherwise, you have to go through and decide what's considered positive or negative here. Okay? Now we look at the screen. In this case, I did designate down as my negative vector. So I can put my negative in here, my negative here, and negative here. Solving this all out, because these are all negatives and a negative squared ends up being positive, we end up with a positive number under here anyway, which we want. We don't want negative numbers underneath our square roots. And I said, well, it's down at 51.5 meters per second. Or we can call it 51.5 meters per second downhill. Okay. Now, that put together gives us a whole list or a network of all these different equations we can use to solve for any variable in one-dimensional motion. Okay. Now that we know that, we can take this information and we can do a lot of practice here, picking out which equation do I use when, what variables do I have, and how does that work? And we'll do that stuff definitely in class. Okay. Thank you guys. We are done.